land, like forest and cultivated land, but also occur in wetlands such as peatland. Next. Peatland have a unique ecosystem that cannot be found in other ecosystems. And in Indonesia, total area of peatland is about 14 million hectares. And then the distribution of peatland in Indonesia is located in several large islands, such as Sumatra, Kalimantan, and Papua. Next. Well, in Siak district, Riau province, have 869,721 hectares of peatland. It means that more than 57.44% total areas in Siak Riau are peatland. Next. So the impact of forest, land, and fire needs to be studied further. One approach in assessing the impact of fire is the fire severity approach, which assesses the impact of fire on vegetation and soil properties. For fire severity, it's based on Forest Law number 41 of 1999 and Government Regulation number 45 of 2004 concerning forest protection article 22, article 23, article 24, and article 25 concerning the importance of implementing forest fire control program, which include prevention, subvention, and post-fire management. Well, assessment assessing the impact of forest and land fires directly on the field is often considered by place and that are both time-consuming and difficult to reach. So, the application of technology is in assessing the impact of land fire needs to be done. So, the aim of this research is to estimate the severity of forest and peatland fire using normalized burning ratio and then using sentinel imagery. Next. Well, this is the method, location and time in May 2020 with the studies areas of Silviculture, Riau Province, and analysis and processing of image data is carried out at the Forest and Land Fire Laboratory of the Authority and Environment IPB University. And then method of data collection, we use hotspot that hotspot is used in this study to determine the image of the period before burning or pre-fire and image after burning or post-fire. And hotspot data is being used to see the range of fire periods. It's also used to estimate the occurrence of forest and land fire. And in this study, the confidence level or the confidence level criteria, we use 18 more than 18%, or it means confidence level high. And then we use Sentinel-2 image because the image use this because Sentinel-2 has a higher spatial resolution than other infrared images that are free access or open source. Next. The normalized burning ratio is designed to highlight burning areas and estimate fire severity. And here's the equation to calculate the NBR. And we can see the level of band in sentinel to imagery. And we use band 8, 8A, and 12. Next. Well, this is the different normal burn ratio calculation or the NBR. The NBR is the comparison result of the pre-fire and post-fire normally burn ratio calculation. The NBR value is that used to find the value of the severity of forest and land fire. And this is the equation of the NBR. And this is the fire severity criteria that we have description of unburned, and then low severity, and then medium to low severity, and then high to medium severity, and the last is high severity. Next. And this is the result of the analysis of hotspot in 2019, which can be seen in figure number 1. Show the highest peak of hotspot in 2019. It's in August. Then the estimation of forest and land fires can be analyzed from a collection hotspot. Land fires that are quite large are not detected as only one hotspot because the heat effect spread to the environment, so that the hotspots are clustered. It can be after night that land or forest fires occurred. Next. This is figure 2 about cluster hotspot distribution that figure 2. So, well, next. Well, the NBR value is used to identify the burning area. The burning area is usually indicated by reddish brown. The color is darker than the surrounding area, and then the shape of the burning area is generally a rectangular polygon, and then the size of the burning area ranges from 0.87 until 249 hectares, and the pattern is irregular, and then the texture is smooth, and then the location of the burning area is generally land cover in the form of shrub, oil palm plantation forest, and secondary forest, and associated with the presence of road and canal. Next. This is example of a normal burning ratio. In image of A, we can see that this is condition pre-fire image, and B is a post-fire image. Next. Well, this is the calculation or the result about different normalized burning ratio is 1,613. Well, the majority of it occur in the Sungai Apit and Mempura Subdivision. Okay, I think that's all. Thanks for your attention.
Thank you very much, Fahri, for very nice presentation. We move to the next speaker, next presenter. I can see here Professor Bambang Hero Saharjo. Professor Bambang will share with us the paper on the high potential of peatland fires management for greenhouse gas emission reduction in Indonesia. Please, Prof. Bambang.
Okay, thank you, Dr. Layan. Please, I would like to run my arm because there is video also there. Sorry for that. So I will start because it's 10 minutes, so I should use my time effectively. Okay. Okay. This is the title I would like to share with you, the high potential of the peatland fire management for the greenhouse gas emission reduction in Indonesia. I will start with this video. Okay. Again, this is you can see here smokes here, the huge at the one side in Langgam, in Palawan, in Rio. Again, this is taken from helicopter. Previous, I show you video on the pit area in South Sumatera, but now a video in Palawan, yes, because usually this district is one of the supporting greenhouse gas in Riau and also in Indonesia. And then the next year, maybe you know all, when the fire comes, this is how the military, police, Bangkala need to try to fight. Can you imagine the big fires with high smoke? Just only use the stick. They didn't care about, the health maybe. And also I didn't understand about the peatland characteristic because in the morning we saw from Mark, yeah, even seems like there's no fire, and we used to use the monitor taken from drone. You see in the ground is still burning. So this is, I think, also we agree in the morning, and also what I discussed before. Don't play the game with the pit fires, because if this fire like this, like I also mentioned Professor Saka, is very hard to control. Then I quote also the paper made by Professor Saka, the pit fires in Asia, particularly Indonesia, are major cause of smokes and particular air pollution, with serious consequences for the human health, because we did our conducted research supported by NASA in 2015, where we got 90 gases, yeah, and then 50% from it is very dangerous to human being. And then here state also by actually about more than 20 years ago, already stated by this Davis and Nunam, stated the local blocking of sunlight can suppress plant photosynthesis. And in addition, peatland are responsible for forest habitat loss and degradation. So this is the reason why I also involved in that kind of environmental destruction, because the link with degradation, for instance, because the fire also responsibility as for peat fire for the flora and fauna. And also, we also in Indonesia, Bulailan also know well about this. We have agreement, some agreement transfer air pollution in Singapore, where I was there in 2002, and finally Indonesia signed the agreement on 2014. And then, because we have a large area of peatlands mentioned by previous speakers, there also become a problem. Because the peat fire emit considerable amount of carbon dioxide, particularly PM, and other trace gases. But now linked with the COVID-19, we have discussed several times before. And also this is, I think, one of the challenges for research together. And then in 2020, we run the research together with the non-parliament organization, NPO, yeah. And then this is the result. Yeah, we conduct in the year 2020 with the main purpose to find how much actually the potential greenhouse gas could be reduced because of this forest or peatland fires. They can be suppressed. And also it is necessary to know how much actually peat is burned, like we have discussed in the morning with Professor Kohran. And then what kind of control measures be taken, like Dr. Lailan mentioned. And then answering this question, then we carry out two major activities. Then we come and bring down, first is literature review, yeah, based on the publication, report, etc. And then also with this one, we conduct the forum group discussion, because sometimes you see we need to make some agreement on it. Otherwise, then we can fight each other because we have different in voting. This is also one of the problem. And then this result again and again. And so you why? Because like I discussed before, yeah, even this is only 1.6, 2.6, but because of it, then the greenhouse increase. You can see here also. Yeah, this data show that if you can handle peat fires, then the huge production of greenhouse gas will increase day by day. Yeah, and then finally it will after there is many activities being done, then this emission will be reduced. Yeah, I've discussed with Mark Brinton from CAMS about the situations. They show that the again and again, like we have discussed before, we should treat it, the peat look like as it at original. Don't let it dry. So because when it dry, then we have a problem. So, and we agree that the fire causes human activities, and then carbon emission result of fire are particularly high as it is extremely rich in below ground organic carbon. And then, for instance, like mentioned by Cohren, we are also now waiting for the publication because they also underestimate or that may make the wrong calculation the peat that burn. This is also become a problem because a certain pitch make general with 50 centimeter. Otherwise, it's very hard to get that one because in each they have their own characteristic. Also, the burn depth also will be different. And then over 90% of peat emission come from reserve. That's the one of the largest one tropical peat carbon. This is also this is made by Pitch that finally put Indonesia as the third largest. I met him in 2016 in UK, and I saw them that you should revise your calculation. We calculate the burn depth because when we calculate with us, the result is different. See, and then Pitch said that, "Mama, sorry, at the time we had no good method to calculate the burn, something like that." So then this is also another reason why I should say that first we should change the calculation. This is made by IPCC, where when you calculate the greenhouse gas emission, especially I connecting with the peat, they put here a combustion factor, yeah, and also the other one, the mass using burn depth. This is at least two factors that make the calculation maybe underestimate or maybe overestimate. Because what? Because in Indonesia they use combustion factor for peat is one, like we discussed. How come? And they make also the burn depth is almost Pitch that finally put Indonesia as the third largest. I met him in 2016 in UK, and I saw them that they should revise your calculation to calculate the burn depth because when we calculate with us, the result is different. See. And then Pitch said, "Mama, sorry, we can't have no good method to calculate the burn, something like that." So then this is also another reason why I should say that we should change the calculation. This is made by IPCC, where we calculate the greenhouse emission, especially I connecting with the peak. They put here a combustion factor, yeah, and also the other one, the mass. Almost using the word there. This is at least two factors.
Presenters, and I would like to congratulate to all of you and thank you very much for sharing your knowledge and experience and for being active participants. And the session will be continued after break. Hopefully you can join the session and after break. And I wish you all the best and stay healthy. Before I close this session, please on your camera. The host will photo our session. Please turn on your camera as a proof that you attend this session. Please. Maybe you can please host to have gallery view. Yes. Host, can you help me to take photo?
Ya, Ibu, baik, Bu.
Okay, please count.
1, 2, 3. Setelah itu, 1, 2, 3. Sudah, Ibu.
Okay, thank you, host. Again,
Thank you very much.
thank you very
See you.
much, all the
Bye-bye.
invited speakers, Prof. Bambang, Prof. Aisaka, and also the presenters, Prof. Acep, and all the presenters.
Yeah.
Thank you very much.
Thank you very
So,
much
this,
to all participants, Professor Bambang,
yes,
Laila,
and also
and
to
all
all
the participants. Thank you very much.
Thank you
Thank
very
you,
much, and
Sensei.
wish you
See
all
you
the
later.
best. See you on the next
Okay.
session. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. And good
Waalaikumsalam
afternoon, everyone.
Tertarik dengan flora fauna yang ada di hutan?
Senang berpetualang ke alam bebas?
Atau ingin turut andil dalam melestarikan hutan di Indonesia?
Fakultas Kehutanan dan Lingkungan IPB University bisa menjadi pilihan yang tepat
Untuk kamu. Fakultas Kehutanan dan Lingkungan IPB University memiliki 4 program studi yang pastinya sangat keren. Pertama, manajemen hutan. Di sini, kamu akan mempelajari cara mengolah hutan, perencanaan, cara memanen hasil hutan secara lestari, baik kayu maupun non-kayu.
Kedua, hasil hutan. Beragam hal bisa kamu pelajari di sini, seperti pemanfaatan hasil hutan dengan baik agar bernilai jual tinggi, dan cara memaksimalkan produk kayu dan non-kayu dengan teknologi yang canggih dan modern.
Ketiga, konservasi sumber daya hutan dan ekowisata. Sesuai dengan namanya, kamu akan mempelajari flora fauna dan konservasi sumber daya yang ada di hutan, serta pengelolaan suatu ekosistem agar dapat dikembangkan dari sisi ekowisata.
Terakhir, Silviculture. Pada program studi yang dikenal dengan sebutan dokternya hutan, kamu akan belajar tentang cara budidaya bibit pohon agar menjadi unggul, serta belajar tentang rekayasa genetika dan perkembangan jenis-jenis pohon.
Untuk mendukung proses pembelajaran, Fakultas Kehutanan dan Lingkungan IPB University memiliki beragam fasilitas yang sangat lengkap. Seperti hutan arboretum, workshop Departemen Hasil Hutan, rumah kaca, penangkaran rusa, hutan pendidikan Gunung Walat, perpustakaan, taman hutan kampus, persemaian permanen, dan beragam laboratorium yang pastinya sangat lengkap.
Gak cuma itu, Fakultas Kehutanan dan Lingkungan IPB University sudah terakreditasi A dan internasional.
Fakultas Kehutanan dan Lingkungan IPB University didukung dengan pengajar yang berkualitas.
Ada juga kegiatan unggulan yang dilaksanakan seperti praktik lapang kehutanan, di mana mahasiswa mempelajari secara langsung berbagai macam ekosistem di hutan, dari mulai hutan pantai hingga hutan dataran tinggi.
Tidak hanya aktif di perkuliahan, kamu juga bisa aktif dalam himpunan profesi dari masing-masing program studi, seperti Forest Management Students Club, Himpunan Mahasiswa Hasil Hutan, Himpunan Mahasiswa Konservasi Sumber Daya Hutan dan Ekowisata, juga Tree Grower Community.
Fakultas Kehutanan dan Lingkungan IPB University berhasil mencetak beragam alumni sukses. Berikut beberapa alumni sukses dari Fakultas Kehutanan dan Lingkungan IPB University.
Bagaimana?
Sudah siap menjadi rimbawan Indonesia?
Ayo gabung bersama IPB University.
Indonesia terletak di lintasan garis khatulistiwa yang membentang dari Sumatera, Kalimantan, hingga Papua. Keindahan alam Indonesia yang terdiri dari pesisir pantai, gugusan pulau-pulau, barisan pegunungan, dan hijaunya hutan belantara menjadikan Indonesia disebut sebagai Jamrut Khatulistiwa. Keragaman hutan Indonesia merupakan rumah bagi berbagai kehidupan yang ada di dalamnya.
Hutan perkasa yang dulu menyelimuti pulau-pulau ini sebagian besar telah hilang. Tinggallah bentangan hutan utuh di Papua sebagai pemilik hutan terakhir di negeri ini. Saat ini, hutan digunduli, sejumlah besar gas rumah kaca yang dilepas ke udara, dan dengan demikian mendorong kita lebih cepat ke titik di mana kita tidak bisa kembali ke dampak perubahan iklim.
Selamat datang di Departemen Silviculture, Fakultas Kehutanan dan Lingkungan IPB University. Departemen Silviculture IPB berdiri pada tahun 2005 yang sebelumnya berada di Divisi Budidaya Hutan Departemen Manajemen Hutan Fakultas Kehutanan IPB. Pada tahun 2013, Departemen Silviculture meraih akreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi serta memperoleh sertifikat ASEAN Quality Network Assurance pada tahun 2015. Pada tahun 2016, Departemen Silviculture IPB dan departemen lainnya di Fakultas Kehutanan IPB bersama-sama menerima sertifikat SNI ISO. Departemen
a very nice oak forest. So we have this in moist climates, we have this in dry climates like here. So it is actually a very diverse topic and diverse, yeah, maybe we need diverse concepts to counteract this. So the situation is for silviculturists, and I'm so happy to have all silviculturists around us. So sorry, I now hear myself in the background. So I have a technical problem because Pak Irianto, I hear myself with a certain time delay. That is a little technical problem. Yeah.
What kind of technical problem?
I hear myself. What I said 30 seconds ago, I now hear fully.
Oh.
Okay, we overcome. Yeah, we are foresters. We also will overcome this problem. Yes. So, okay, let me just start and ignore my own voice from 30 seconds before. So the situation is we have altered environmental conditions like soil compaction, a loss of soil fertility, and other constraints. We have a change of landscape and previous hydrological regimes. And ladies and gentlemen, 1 second, there is a technical problem. So let me log out and come again to solve this problem. Is it okay for you, Pak Irianto?
I think it's
Have restoration cost versus benefits because there are no trees to be sold, something like this. So harvesting could not compensate for doing something productive. So we have to invest. And the most missing is that we don't have, very often, we don't have written records of what has been there before. Yeah, so what has been there 100 years before in central Kalimantan and what has been there 150 years before in Iran. So we are missing written records on the land uses at that time. So the challenges are, we should regain ecological functionality and enhancing human well-being across these deforested and destroyed forest landscape. So we see ecological functionality that has something to do with the forest itself and enhance human well-being, because forestry means forest and people and forest. So in this combination. And this is more than just planting trees, because restoring the whole landscape needs to meet present and future needs. and present and future needs have to be evaluated. What the present needs we may ask, the future needs we need to predict, and we look into the future and to foresee necessities of the future. So, and then offering multiple benefits and land users over time, because in a landscape, there are so many stakeholders and they all expect advantages over time. So, and we should find ways to satisfy them as possible, as ever possible. So, and third is developing a long-term vision of the ecological functions and the benefits of human well-being. So we have to think at least a rotation of 30, 40, 50, 60, 80 years. So now this big problem of these 2 billion hectares, this made the international policy alert, and there was this so-called Bonn challenge that was a major meeting in 2011, and the goal was a global goal to bring 150 million hectares of degraded and deforested landscapes into restoration by 2020. Now we have 2021, and we should see what has happened. And 350 million hectares by 2030. So this is a world map optimistically articulated as world of opportunity. And there we see huge areas in green and light green and a little bit brownish, which have at that time be identified as suitable for forest landscape restoration. The principles of this forest landscape restoration project formulated on this Bonn challenge was first the focus on landscape, not individual site, but land uses and management practices under various tenure and governance systems, then maintain and enhance natural ecosystems, but on a landscape scale, then engage stakeholders and support their participation, then tailor local context using a variety of approaches, so social, cultural, economic, ecological values, needs, and history of the landscape, then restore multiple functions for multiple benefits, ecological, social, and economic functions, so you see how diverse this is, and manage adaptively for long-term resilience. This was the very official postulation, and we can break this down to these 2 points. Re-establishment of functional forest ecosystems. So I see this is something for foresters directly. Functional forest ecosystem, it means growth and regeneration, autonomous development. And the second is local livelihood improvement. And that we are very aware when we go to rural areas that we have to do something for the people, we have to support them. So these 2 points actually are the essence of all these complex visions. And the strategies are, now we come to the strategies, how to do this. We need to know in such a depleted landscape, what has there been before to recreate a functioning ecosystem, forest ecosystem. And so if ever possible, we should take a primary forest as a reference. And we close to nature forestry in silviculture, we know how to do it. Or what we don't know, we are ready to learn it. Yeah. Then the second point is the priority should be the local flora. So local species rather, whenever possible, than exotics. Then an appropriate species site matching. So adapt the relevant species for the site of the area with the respective site, even if the site has been changed due to mismanagement. Then apply established forestry knowledge. And we all know this forestry knowledge is there. It is there in Bogor, it is there in Leite, it is everywhere in the faculties of forestry, including Göttingen. So we have it. We just need to unwrap some of these, what we need. Then further livelihood improvements, and livelihood improvements, the forestry sector also has good experience in terms of agroforestry and, for example, local labor priority for restoration projects to bring benefit directly to people in the land, on the land. And for example, value chain of the NTFPs and local products should remain as much as possible in the area and other aspects. So now I come to the planning process, and that is actually the most important. That is, I may say, this is a table of content, a proposed table of content for a forest restoration management plan. And these are 17 steps. So it's a mix of different aspects, and I try to compile them. They are not all my ideas, but I try to compile them to make it feasible. And what is with Antares, you see here, or in red, these are these points which are exclusively relevant for this forest landscape restoration. So first, to make such a plan, for example, a 10-year plan, like in forestry, which is common in forestry, we have to build up a planning team. Then the second is we have to get background information, climate, soil, vegetation, and the area history, and of course, what has been there before human impact appeared. Then a field inventory. We are all aware what is a field inventory. We learn it in our curricula. It is an integrated part of it. So pristine forest reference, if available. So we have to make an inventory. Then an inventory of the target area of this destroyed landscape, and an inventory of successional stages, if ever possible. Then the next step would be derive data of species site adaptation, their structure and function, and the rank of species towards site factors. How do the different tree species react to specific site factors like inundation or drought or salinity, or it depends what site factors are of relevance in the target area. Then assess limitation of target area, environmental, economic, political, administrative, or legal. Then review in regional interrelationship or actors and stakeholders, which Kripala Desa does not want something what the party wants or something like this. And those have something to say on the land. So to see these differences, these difficulties, and try to solve them in order to find a good solution, an appropriate solution for this land. Then states the objectives of the area, divides the area into management zones, reviews the boundary of the area. That is very common in forestry in general. But now, then we have to design the forest landscape restoration program, tasks, actions. We have to define them. We have to brainstorm. We have to prepare integrated development options, infrastructure, nursery, train the staff in the right way. We have to outline financial implications, cost estimation, cost-benefit analysis. This is, of course, essential. And then we prepare and distribute a draft plan. Then this plan has to be revised, has to be discussed, and so on. And later has to be published and accepted by the key stakeholders. And that is then a management plan which could be ready to be improved, accepted, and could come into action. So actually we have everything, the forestry sector has everything necessary for this work. There's a lot to do for this work. What we need, what is very essential is that we get more information on our local tree species. Yeah. That is very important, and their site adaptability, that is very essential, that we focus if we want to work in this, and this forest landscape restoration has a big potential. I think there's a lot of funding available soon that we need to train us more in close to nature forestry a little bit more than we have done already. Yeah, so this is some references. And then I would like to thank you very much and still apologize for coming too late because I missed the other way around. I thought Indonesia is forward in time, but it's just the opposite. So I apologize to come too late.
Okay.
Thank you very much.
Okay.
Thank you.
Okay. Thank you. Thank you so much, Prof. Ralph. So it's absolutely fine, Prof. Ralph. It's also maybe our mistake that didn't inform you from the first that we have just 6 or 7 hours difference between the countries. Okay, but anyway, do you have a time for around 30 minutes, Mark? Prof? Hello?
Yes, yes.
Okay.
Sorry.
Yeah. Do you have another agendas for today, or do you have?
No. I'm completely here for you.
Okay.
Thank you.
Okay. Thank you so much, Prof. Then we will hear some presentation from the students, if you don't mind. Then after that, we can have just like a discussion session for maybe 20 minutes, if you have a time.
Thank you very much. Thank you very much.
Okay.
Yes.
Thank you, Prof. Ralph. And for the next speaker will be Citra Septianti Putri. Citra is here?
Yeah.
Okay. You have 10 minutes, Citra, to present your papers. And after that, we move to another presenter, Farah Sabina. Okay, time is yours. Please use the time appropriately. There's a problem with your share screen, Citra?
Yeah, for the share screen is from me or from the ICTS committee?
Oh, so which one is better for you, from yourself or from the committee?
From the committee, but in my Zoom is not responding. To
Not responding.
Yeah.
So I think you can change the. Is that a problem with the committee for share the screen?
So
No.
May I share my screen?
Okay. I think it's better you share yourself, Citra. Sorry for that.
Okay.
Okay. Screen sharingnya di. Okay.
Okay. Assalamualaikum warahmatullahi
Okay, please.
Yeah. Okay, good afternoon. Thank you, Pak Indra, for the opportunity. I'm Citra Septianti Putri, and on this occasion, I'm going to present the result of my research titled The Chemical Properties of Burn Pit Soil in Teluk Bakung Village, West Kalimantan. First, here is the outline of my presentation. For the introduction, peatland is a wetland ecosystem formed by the accumulation of organic matters on the forest floor from the debris of the vegetation above it over a long period of time. This accumulation occurs due to the slow rate of decomposition compared to the rate of accumulation of organic matters on the wet forest floor. Noor added that tropical peat soil are formed through a paludification process. Because of the unique materials and formation processes, the properties of peat soil are different from the mineral soils. The peatland has a low density, high acidity, very high organic matter content, high porosity, and high cation exchange capacity value. Peatland have a very important role for human life and other living things. The peatland as a source of freshwater fish, habitat diverse living creatures, food control, and etc. And peatland also has a role in global climate control because of their ability to sequester and store carbon. The increasing demand for land in various sectors has led to land clearing activities in peat areas. Land clearing is done by logging or burning, and it affects the properties of peat soil. Peatland management by burning can affect the chemical properties of peat. In the short term, fire that destroys soil organic matter can affect on increasing nutrient availability, according to Firmansyah and Subodh 2012. And the study aims at analyzing the chemical properties of peat soil on 4 land management areas in Teluk Bakung Village, West Kalimantan. For the method, this research was conducted on 4 land management areas in Teluk Bakung, which is burn land, taro plantation with burn land management, taro plantation with unburning land management, and rubber stand. So samples were taken in plot measuring 20 meters times 100 meters at each location. Disturbed soil sample used for analysis of chemical properties. Disturbed soil samples were taken from 5 points in each plot using a shovel at a depth of 10 till 0 centimeter. All soil samples were composite evenly to take 1 kilogram and put into a plastic bag. The chemical properties that were analyzed is soil acidity, soil organic carbon, S content, nitrogen total, available phosphor, cation exchange capacity, and base cation. And for the result, first is soil acidity. Peat is generally has a high acidity level. According to Hartatik, peat soil in Indonesia are mostly acidic to very acidic with pH value less than 4. Based on the result, the highest soil acidity is in taro plantation with non-burning land management or TTB with value of 4.64, followed by taro plantation with burn land management and followed by burn land or 80 and rubber stand or takey with 2.97. It might be effect of the application of lime to land preparation in taro plantation with non-burning land management site. The application of lime on peat soil is technically the best thing in increasing the pH value of peat soil. Ilham added that effect of lime on peat soil can improve soil pH value, base saturation, increase calcium and magnesium element, and reduce the availability of toxic organic compound. Next is for soil organic carbon. According to Hartatik, peat soil is formed from a pile of organic matter so that the carbon content in peat soil is very large. And the result showed that rubber stand is the highest soil organic carbon compared to the other 3 sites with a value 53.66%. It might be influenced by the higher input of organic matter in rubber stand. Aristio reported that adding a lot of input or adding organic matter to peat will increase the content of existing organic acid, so that there will be an increase in the organic carbon value in the soil. For the next is S content. According to Noor, the S content of peat soil in Kalimantan has a value between 11 to 41%. And the S content of peat soil indicates mineral content in the soil, which is negatively correlated with organic carbon content. And based on the result, taro plantation with burn land management has the highest value of S content with 14.91, followed by taro plantation with non-burning land management, burn land, and rubber stand. Nor added that peat S content is very low, except in soils that have experienced fires or have been cultivated intensively. Next is for nitrogen total. Based on the result, the nitrogen showed that the highest nitrogen is in burn land with 1.79, followed by taro plantation with burn land management, taro plantation with non-burning land management, and rubber stand. According to Agus, the total nitrogen content of the tropic peatland in some areas in Indonesia range from 0.3 to 2.1%. The high value of nitrogen in burn land can be affected because of mineral element that released due to fire. Purnomo also added that the increase in nutrients was caused by the addition of nutrients from ash of biomass combustion. But the availability of post-burning nitrogen nutrient increased, but the increase only effect in the short term. And for the next is available phosphor. Based on the result, the highest available phosphor content was in burn land with 153.69, and followed by taro plantation with burn land management, taro plantation with non-burning land management, and last is rubber stand. The increase in available phosphor in fire is caused by the release of organic phosphor and mineralization of soil mineral matter as a result of high temperature. Sulaiman also added that burning is beneficial in increasing the pH value and converting the unavailable phosphor, which is stored in peat organic compound, into available forms. And for the cation exchange capacity,
Citra, you have 2 minutes more.
yeah. The value of cation exchange capacity in peatland is very high. According to the result, the burn land has the highest value compared to the other three sites with 113.39. The residue of the burning process could increase cation exchange capacity according to August 2019 and Mintari 2019. And the last is for the base cations, and the result showed that for the calcium and magnesium value, the taro plantation with non-burning land management has the highest value with calcium for 22.38 and magnesium is 6.36. This might be influenced by liming activities during land preparation, and the result of the study of Ilham also added that there was an increase in the value of calcium and magnesium in peatlands that were given dolomite lime. And for the potassium and sodium, based on the result, the highest value was obtained in burn land, with potassium value is 2.78 and natrium value is 4.48. This might be affected by fire that occur in the area. Generally, fire increased the availability of all cations. Ralph added that burn peat soil will have a high potassium value because land fires will increase the concentration of exchange bases in the soil, including the potassium value. However, Agus added that the change in the chemical characteristic of soil took place temporarily. And for the conclusion, the result of the study showed that the parameters of the chemical properties at each site had various value. Burn land had the highest nitrogen, phosphor, potassium, sodium, and cation exchange capacity value. Meanwhile, the highest pH, calcium, and magnesium value were in taro plantation with non-burning land management. Then the highest S content values were in taro plantation with burn land management. For the value of soil organic carbon, rubber sand had the highest percentage compared to the other land condition. And this is the references that used in this presentation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Citra. Nice presentation and nice results. So for the audience, just keep your question. We will have a discussion after presentation of Lara Raffi Ayuningrum. So in the next 20 minutes. Okay, then the next presenter will be Farah Sabina Hadiani. Okay, you have 10 minutes. Time is yours.
Can you hear me? Is my voice clear enough?
Yes.
Okay.
You can continue.
Yeah, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Farah Sabina Hadiani, and I will be presenting the result of my research, hotspot analysis in 2015 and 2019 in Ogan Komering Ilir, South Sumatra Province. Next. Here's the outline of my presentation. Next. First, introduction. Next. Forest and land fires are environmental issues that frequently occur in Indonesia and around the world. The biggest fires in Indonesia occurred in the last decade, occurred in 2015 with a burn area of 2.6 million hectares. A fairly severe fires occurred again in 2019 with a burn area of 1.6 million hectares. One of the provinces that experienced a severe forest and land fires is South Sumatra Province, especially Ogan Komering Ilir District. Ogan Komering Ilir District, or Oki District, known as one of the districts in South Sumatra that experience severe forest and land fires every year, especially in 2015 and 2019. As an effort to prevent fires in Oki District, an analysis of hotspot and the factors that influencing them was carried out. One of the factors that influencing hotspot number is rainfall. Next. The purpose of this study is to analyze the hotspots distribution in Ogan Komering Ilir District, South Sumatra Province in 2015 and 2019, and the relationship to hotspot and rainfall. Next. Second, study location. Oki District is one of the districts in South Sumatra Province with 19,023.47 square kilometers area. Oki District has 18 sub-districts. Oki District consists of various elevations, start from 0 meter above sea level to more than 30 meters above sea level. Oki District is classified as a wet climate with an annual average rainfall of more than 2,354 millimeters per year. Oki District has the largest peatland in South Sumatra Province of approximately 639,122.2 hectares, or equivalent to 50.64% of the peatlands total in South Sumatra Province. Next, methods. The study was carried out from January to May 2021 in Forest and Land Fires Laboratory, Faculty of Forestry and Environment, IPB University. The tool used in the study was a set of computers with several programs, and the material used in the study were hotspots, distribution data, administrative boundaries data of Oki District, map of peatland distribution, and rainfall data from 2015 and 2019. Next. Here's the data processing procedure. And analysis methods that used in this research are descriptive data analysis and simple linear regression analysis, with the test level used is 5%. Next. This is the accumulation of hotspots number on each district in South Sumatra Province from 2015 to 2019. Oki District has the most hotspot number with 22,743 hotspots in those ranges of years. Oki District in 2015 and 2019 has the most hotspots than the other district. The number of hotspots in 2015 is 17,532 hotspots, and in 2019 is 4,583 hotspots. The intensity of El Nino phenomenon that seems to be the cause of this severe fire. The El Nino intensity in 2015 is classified as very strong, while the one occurred in 2019 is classified as weak. The intensity of El Nino phenomenon can be seen from ONI value or Oceanic Nino Index. Next. From all 18 sub-district in Oki District, Tulung Selatan sub-district has the most hotspot in 2015 with 5,962 hotspots, and in 2019, it's Cengal sub-district with 1,372 hotspots. Meanwhile, the sub-district with the least hotspot is Mesuji Makmur sub-district with 2 hotspots in 2015, and in 2019 is Lempuing sub-district with 0 hotspots. The number of hotspots that was found is related to peatlands area in each sub-district. Tulung Selatan and Cengal sub-district are included to the top 3 sub-district with the largest peatland in Oki district, while Mesuji Makmur and Lempuing sub-district has no peatland. Next. The number of hotspots on peatland is relatively higher than the number of hotspots found in non-peatland. In 2015, the number of hotspots found in peatland was approximately 12,360 hotspots, while the number of hotspots on non-peatland was 5,172 hotspots. The number of hotspots in 2019 in Oki district on peatland was 2,047 hotspots, while the hotspots number on the non-peatland was approximately 2,536 hotspots. The total number of hotspots from 2015 and 2019 on peatland was around 14,000, while on the non-peatland is around 7,000 hotspots. Hotspots on peatland are caused by the peat's characteristic as fuel. Peat has an irreversible drying characteristic, indicating that when the peat is dry, the peat soil can absorb water again, or loses its ability to absorb water. Next. The amount of hotspots on peatland can be seen on the map. The hotspots on the dark green part are more compact than the hotspots on the lighter green part. Next. Here's the graphic of monthly hotspots number and rainfall at Oki district. In the beginning of 2015, the rainfall in Oki district was pretty high. From January to June, the rainfall is above 100 millimeter per month, and the hotspots that were found is about 4 to 34 hotspots. The rainfall was significantly dropping to 21.4 millimeter per month on July with 97 hotspots. The hotspots increasing throughout the months until its peaking at October with 9,364 hotspots and only one rainy day in a month. In the beginning of 2019, the rainfall was pretty high too and ranges from about 100 to 400 millimeter per month. The hotspots that were found was no more than 10 hotspots per month, but it's significantly increasing on July with 22 hotspots, and the rainfall dropped to 96 millimeter per month. The number of hotspots keep increasing and peaking at October with 2,053 hotspots and with only 0.2 millimeter per month rainfall. Next. On wet month, the R square on the table shows the presentation of rainfall effect towards the hotspots number. The R square on 2015 is 0.26, and on 2019 is 0.22. It means that the rainfall on 2015 only affecting 26% of the hotspots number, while the rainfall on 2019 only affecting 22% of the hotspots number. P-value on both years are more than 0.05, means that the rainfall on both years in Oki district is not significantly affecting the number of hotspots. Next. Conclusion. The conclusion of this study is, first, the number of hotspots in Oki district in 2015 was about 17,000, and 12,000 of them are spreading on peatlands and 5,000 others are on non-peatlands. The number of hotspots in 2019 was 4,000, in which 2,000 hotspots were found on peatland and the other 2,000 hotspots were found on non-peatland. Daun Selatan Subdistrict had the most hotspot in Oki District in 2015, while the highest number in 2019 was in Cengal Subdistrict. Rainfall in 2015 and 2019 had no significant effect on the number of hotspots. In 2015 and 2019, the number of hotspots increased in July with low rainfall. Rainfall and hotspots had an inverse correlation. Next. This is all I can present to you. Thank you.
Okay. Love it. Nice timing ya, Farah. Your time is 10 minutes, 1 second. I like it. I like it. Okay, the next presenter will be Rarafati Ayuningrum. Are you there? Okay, Rarafati, time is yours. Use the time properly ya. 10 minutes.
Mr. Arianto. Bismillahirrahmanirrahim. Thank you, Mr. Arianto Infrastructure, and good afternoon, everyone. On this occasion, I will present the result of my research analysis of the distribution of hotspot and burn area in Muaro Jambi District, Jambi Province. Next. Okay, the condition of forest in Indonesia has many disturbances, including forest fires. Forest and land fires are becoming worse and uncontrollable, which are supported by weather such as dry season that occurred in 2015 and 2019. One of the provinces in Indonesia that is prone to forest and land fires is Jambi Province. Forest fires in Jambi Province often occur in Muaro Jambi District. Fire control with hotspot detection can facilitate efforts to prevent and extinguish forest and land fires. Forest and land fires can be detected through hotspots, which can be used as an indication of forest and land fires. Based on the largest fire incidents in Indonesia over the last decades, the distribution of hotspots in 2015, and 2019 needs to be analyzed. The existence of an analysis of the distribution of these hotspots can be used as an effort to prevent further forest and land fires. Next, please. The data that I used are hotspot in 2015 until 2019 from NASA Modis Terra Aqua, and there's data administration of Indonesia from Indonesia, and map of peatland distribution from R&D, and rainfall from BMKG. Next, please. For method, there are data processing and data analysis. Data processing was carried out by making a map of the distribution of hotspots in Jambi Province. The mapping was carried out using ArcMap 10.3 software and NASA Modis Terra Aqua hotspot data with a hotspot confidence level of 30%. The data analysis useful for providing an overview piece of data. In other words, descriptive analysis can provide a description of the conclusion on data that have been presented. Next, please. Figure 1 shows that Muaro Jambi District has the highest number of hotspots in 2015 until 2019 compared to other districts in Jambi Province, that is 6,132. The number of hotspots in 2015 in Muaro Jambi District was 2,731 and 3,321 in 2019. According to RPGMD, land use as plantation and agriculture sector in Muaro Jambi District is the largest land use area. A large number of farmers are converting land to oil palm. Of course, the transfer of land use using the burning technique because it is considered more efficient and cheaper. The burning continues to become uncontrolled forest and land fires. Next. Figure 2 shows the highest number of hotspots in peat areas. In 2015, the number of hotspots in peatland was 2,558 and 3,225 hotspots in 2015. This can happen because the area of Muara Jambi has a fairly large area of peat. In addition, the El Nino phenomenon that occurred in 2015 and 2019 exacerbate forest and land fires. Forest and land fires are often cause the peat loss of soil moisture and water content. The spread of fire peatlands is influenced by rainfall. With increasing rainfall, the availability of water in peatlands increase, which will make it difficult for the land to burn. Next, please. The distribution of hotspots in 2015 and 2019 was seen to be dense in peat location in the area around Kumpeh district. Figure 3 shows the density of hotspots in the Kumpeh area and its surroundings. Hotspot density has an important role in fire vulnerability. The greater the hotspot density, it will provide a higher level of vulnerability compared to the areas that show a little hotspot density. The plantation sector is a very important part in supporting the direction of development in Jambi province. This shows that the use of peatlands for plantations area is very high. Next, please. For figure 4, it shows that Kumpeh district has a total of 2,329 hotspots in 2015 and 2,868 in 2015. The high number of hotspots in Kumpeh district indicates that this area is prone to forest and land fires. Sungai Gelam, Kumpeh Ulu, and Taman Rejo sub-district are located around the Kumpeh sub-district, which has a lot of hotspots, and this can happen because the sub-district in a peat area. On the other hand, areas that do not have peat areas, such as North Bahar, South Bahar, and Sungai Bahar, have a few or even hotspots. Next, please. For figure 5, it shows that in 2015, the highest number of hotspots was in September with a total of 995 hotspots, and the lowest rain amount to 15.2 millimeter a year. And the decrease in rainfall was followed by an increase in the number of hotspots from May to September. In 2015, the highest number of hotspots was in September with a total 2,556 hotspots and had the lowest amount of rainfall with the amount of 39.3 millimeter a year. A low rainfall can make a litter or flammable materials easier to dry, and this can facilitate the burning process for land clearing or land use change. Next, please. In 2015, the area reached 15,855 hectares, and the fire area in 2015 reached 43,534.8 hectares. Peatland fires are a serious problem because catastrophic fires on peatland occur almost every year. In addition, El Nino storms can affect the extent of fires in Muara Jambi district. The long dry season causes the emergence of hotspots as well as forest and land fires. This can be used by some people to facilitate the process burning of burning land. Next, please. Okay. Figure 7 shows us that the area of fire marked in the dark red on the map extends from 2015 to 2019. On average, fires occur in peatland compared to mineral areas. This can indicate that the area that is prone to fire peat area. The development of oil palm plantation area in Jambi province is inseparable from the development of oil palm plantation area. Jambi is the largest palm oil production center in Jambi province. Next, please. Okay. And to the conclusion of this study is the highest number of hotspots were mostly spread on peatlands, and Kompes sub-district has the highest number of hotspots, which has the largest peatland. And September in Jambi district is the peak of dry season and mostly burn area found on peatland. Prevention of forest and land fires in peat areas has not been maximized due to a lack of public awareness to maintain and protect environment sustainability. Next, please. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you so much, Mbak Rara Fatih. So we come to the discussion session. We have around 15 minutes. Sorry. I will check. Is there Ise Afifah is in the room? But the next presenter should be Ise Afifah. Ise Afifah is in the room. No, I don't think so. So how about Pak Sigit Sutikno? Actually, we have 5 presenters, Rob, but I think the 2 presenters from them are having another conflicting agenda. So, okay. We are coming to the discussion session. We have around 15 minutes. So any one of you that has the question for Pak Rauf or Bu Citra or Mbak Farah or Mbak Rara Fatih, please raise your hand or okay, or write your question in the chat room. I think it will be fine if you are worried to ask in English. You can ask in Bahasa. I think Pak Rauf is also understand Bahasa ya Pak Rauf.
Yes. Few words, it's true, yeah. Don't worry. Need not to be shy.
Yeah.
I'm also not shy. You know.
Yeah, don't be shy to speak in English ya Pak Rauf ya. Because if you don't speak, everyone didn't know you can speak English or not. But if you speak, but if you speak and you are wrong, so we can correct your pronunciation and so on.
Please.
Yeah.
Yes. Can I ask a question first?
Okay.
Because so many ladies, they talk about fire, fire in Sumatra and Kalimantan. And my question is, this fire application, is this very much linked to palm, to oil palm plantations, or are there also other reasons?
Okay. Who will answer the question? Citra, please, you can answer, I think.
Maybe I give it try. So I think the fire and oil palm is any relation because in this in my location some of the site is burned and then after a year it became a oil palm plantation, but in my location it's not big, very big, or for it's not for perusahaan. It's not for
Company.
it's a company, but it apa, dikelola oleh masyarakat.
Managed by
Managed
the
by
local people.
the local, yeah.
Yes. So,
Yes,
Rob, yeah, actually, we have maybe some problem with the oil palm because many of the companies are using fires just to prepare the land. So before they start planting the new oil palm plantation, sometimes they just use the fire because fire is very cheap comparing to the mechanical land clearing.
Can I ask a little side question to this, or is it not okay?
Okay, it's fine. We still
Because
have time.
I have been to Sumatra, to Sungai Air River,
yeah.
and there's a peat. The peat was 10 meters.
Oh.
Yeah, there was still gelotong growing in the natural forest, ramin, and it was 10 meters. Does it mean that all these 10 meters will burn, or how much will burn from these 10 meters? How much? Just to understand, yeah?
Yeah.
That's my question.
Okay, thank you so much. Rafati, Farah, wanna answer? Oh, they are answering by a smile, Rob.
Yes. Maybe that's the best answer.
Okay, it's just like a tricky question, yeah, because gelotong is the endemic species for the peatland, so gelotong can grow better in the peat, yeah. And if you ask how many meters they burn, I think it's depend on the location and depend on the lot of parameters that we have to concern about the peat burn and how deep is the peat burn and so on, because it's related to the groundwater level, regarding to the water content of the peat, yeah, and regarding of the hydrology and so on. So I think the tip of the peat burn is vary from place to place.
Thank you.
So,
thank you very much.
Yes, there's a question from Andita Minda. You raise your hand, Andita. Okay, please, Andita Minda. You wanna ask something? You have a question?
Yes,
No?
I have a question for Prof. Love.
Okay. Okay, and you
about
have no answer.
About the
Okay.
management strategy that we use to manage forest fire, that very wide and comprehensive to do. I'm concerned with the fuel as the strategy for land fire management, but it is so difficult to apply on the field. And I want to ask, do you have advice for us for manage land with the wide and comprehensive in the field? Just it. Thank you.
Okay. Thank you, Andita. That's a very good, nice question. Yeah.
Thank you very much for you ask me an idea of management to prevent fire, yeah? To prevent fire. Was that your question?
Yeah, I think the question is how to manage the how to manage or to restore the land after the fire.
After the
Just
fire.
like a land fire management. Yeah.
Yes. After the fire, usually there will be a succession. I think first a fire in the evergreen moist forest or in the peat swamp forest, ramin, gelotong, and so on. Previously, there has rarely been any fire because this is evergreen moist forest, swamp forest. It's wet, wet, wet. So under natural conditions, I think there are no fires, even not exceptional fires. These came only with humans going there to make the land, to change the land uses. So from the natural conditions, I think there is no strategy of the previous species, of the local species, to catch up with fire. Not like the pine forest in Kirinchi. The pine forest in Kirinchi, they are adapted to fire. Yeah, there is a strategy.
Yeah.
But these peat swarm species, I think not. So what could be done is, first, there should not be a lot of fuel on the forest floor, because fuel encourages the fire. There should be a very strong education of local people to avoid the fire. And when you build up the forest close to nature, then please consider, first, of course, the different pioneer species, find out which are the pioneer species, and make it as diverse as possible in terms of species and in terms of age and structure, as diverse as possible, because that will limit the fire movement and these aspects. Yeah, that would be my recommendation. I'm not expert in fire at all. I'm not expert in fire at all, but this is a first idea. Yeah.
Okay.
Yeah.
Thank you, Rob. So, is there any other question?
Can I have a question?
Okay,
sir?
okay. Please, Alvin.
Is my sound audible?
Yep.
Yes.
Okay. First, let me introduce myself. My name is Alvin, and I'm from Indonesia. And I have a question for Professor Raf about species matching in forest restoration. So my question is actually about, for example, if you want to do a forest restoration in Kalimantan, and when you want to plant the seeds of a forest, can you actually bring a different species from different island? For example, you bring a species of trees from Sumatra, and then you bring it and plant it on the Kalimantan. Is that possible, or does the same species is actually essential for forest restoration? Thank you.
Thank you very much. That is, of course, possible. Of course, this is possible. But forest landscape restoration is usually a concept, an international concept, which could bring a lot of funding for the activities, for the planting, for the management, external funding. And these who have a strong interest in this is a nature conservation sector. And the nature conservation sector, IUCN and so on, they promote this forest landscape restoration very much, but they also demand some natural forest, I mean, or close to nature forest. And when you want to bring up the previous forest ecosystem and you take an exotic from somewhere, then this might not fit well to the previous ecosystem. We need not to do forest landscape restoration. We need not to do this. We can do plantation, can do close to nature with exotics, whatever we want. Of course, we are free, and the land owner is deciding what he wants, that's it. But if we stick to the forest landscape restoration and hope to attract funds through this scheme, then we should find ways that the forest ecosystem can function itself without human interference and can develop back to what it was before. Yeah. Thank you very much.
Okay, thank you, Rob.
Thank you, Professor, for the answer.
Yep, I think. Thank you so much for the discussion. There should be a lot of question and this to be discussed here, but time is limiting us because now we have to move forward to the next session, the third session. So from our session, we can grab a lot of new thing and new paradigm of how to restore our forest landscape. Prof already gave us a broadened view of both the history, the benefit, and also the strategy to restore the forest landscape, and also how and we have to bring it to close to the nature, just like that. And from the second presenter, we learned that the land management and the burn land is affecting much the chemical properties of the pit soil. And from the third and fourth speaker, we can learn the couple of the precipitation and the hotspots. I think this one is very, the scientific atmosphere in this session is very nice. I love it, but Prof, we have a time limitation. Then if you have a time, we still have another session, Prof, if you want to join. But if you have another agenda, so we already feel very happy to have you here. Finally, we can meet here in the conference. Okay, please.
Can I say one word?
Okay.
I may run away in between because of a different term I have. Yeah. So thank you. In between, silently. So thank you very much.
Okay. Thank you very much, Prof, for sharing your experience and for sharing your knowledge for us here. And thank you for Chitra and also Farah and Rafati. Thank you so much for sharing your research result with us. Hopefully, we can grab a bright future in the future. Yeah. Okay, thank you so much. Please give a big applause for our speakers here. Okay, thank you so much. I close the session. Assalamualaikum warahmatullahi wabarakatuh.
Yes, dokter.
Hai, apa kabar?
Baik.
Okay. So I think we only have 3 presenters for this session. So each speakers will be given only 10 minutes for your presentation, and we'll have 15 minutes discussion at the end of our session. Okay. And I also like to remind all participants for this session to ask your question. If you have any questions, you can just type your questions on the chat box. And if you want, you could also interact with our speakers during the discussion session. Okay, so without further ado, I would like to invite our first presenter, Mrs. Anita Mindamura from Faculty of Forestry, Graduate School of IPB, with her title Mapping Wildland Flows for Fire Management in Berbak and Sembilang National Park across multiple skills, integrating remote sensing, GIS, and biophysical modeling. So the floor is yours, Ms. Andita.
Thank you very much to give the opportunity to me to present my paper with the title Mapping Wildland Fuels for Fire Management in Berbak and Sembilang National Park across multiple scales, integrating remote sensing, GIS, and biophysical modeling. Please, next. Okay, wildland fuel is a number, the role they play with the burn in the wildland fire. In ecological context, the fuel is mean biomass. This combustion material, the biomass material, are the leaf and that organic matter that ecologists call as biomass that can burn in the specific area. Wildland fuel are critical element in many wildland fire planning and management activity. And then the fuel role the describe of physical character for our fields in the area in the Berbak National and Berbak and Sembilang National Park. The fuel is matter because my step in dissertation, and its a paper is a review for fuel map and the fuel map that another country use in the worldwide. You can see the pictures that the picture of the fuel in the land forest. We have crown fuel and then surface fuel and the ground fuel in every canopy and every layer of the forest. Next, please. The objective from this research, like I said before, is to review the past, present, and future approaches from mapping fuel for fire management at multiple scales, and then review the historical fuel mapping approaches to prepare that accurate digital fuels maps in Berbak and Sembilang National Park. Next, please. It's a literature review of mapping fuel for 10 years past for multiple scale for fuel fire management. That said, all of paper said that the creating wildland fuels map is quite difficult, especially at landscape to regional scale for a number of reasons, like a lack of resources such as limited georeference fuel data and inadequate fuel classification, coupled with a variety of ecological concerns such as fuel beds being hidden by the canopy and the scale mismatch in the field data, imagery and analysis technique often complicate fuel mapping efforts. Next, please. This is a table that approach used to map fuel for fire management. We have 4 approaches that used in the past, present, and will use in the future. The approach is file assessment, and then association, and then remote sensing or GIS, and then biophysical modeling. You can see the description and the advantages and disadvantages for some of the approach that we have to use to fire management, and the interaction of the 4 major for process controlling the fuel dynamic on the surface and canopy in the fuel strata. Next, please. So the challenge is for the review of the paper, we found that the challenge to mapping fuels for fire management in the multiple scales, the accuracy of fuels map that varies widely, but in general, most fuel maps have a low accuracy. When the accuracy assessment were reported that usual range between 5 and 85% correct, regardless of fuel mapping approach or integrative strategy. And the second, accurate fuels layer are costly to build because they require abundant field data and an extensive expertise in the wide variety of spatial field in remote sensing and geographic information system, and the fire and fuel modeling, and then imaging process, and then vegetation mapping, and of course a comprehensive knowledge of fuel that must we have to build the forest fire to the fuel mapping. The third is fuel are notoriously difficult to map because of their highly variability and disparate spatial distribution across the every component that we found in the field. Next, please. And the objective 2, historical field mapping approach to prepare accurate digital fuels map to make a fuel fire management in Berbak and Sembilang National Park. The historical for the review that we found that most fuel beds were described using terms that relate more to fire behavior than ecology. So every researcher that found fire behavior than the fire ecology. That's how we make the difficult to make sure the result and the ecology in the field, and make the difficult to prepare the accurate digital fuels to map the forest fire fuel. And 1930, the correlated fire behavior and firefighting descriptor to vegetation cover type represented fuel and cold category in this classification by hour and control zones. In every fuel, every research called the fuel characteristic with hours and control zone with the they fuel can burn. And then in 1935, described fuel of the Northern Rockies category in an ordinary fire behavior classification, and then describe the map fuel for many other areas, and its use of until now in some country. And David and Brown also recognize several reasons why fuel description based on fire behavior were ineffective. And then in Indonesia, we adopt the algorithm from the Canadian forest fire danger rating system to fire management strategy, and developing based on and we want to make a fire management strategy based on the local condition in Berba and Sembilang National Park as representative peatland soil in Indonesia. So the generic algorithm will be fit on every site where the peatland is measure the soil type. Next, please. So it's the conclusion. First, map depicting characteristics are essential to fire and land management at many scales. Fuel maps are difficult to create because of the obstruction of the forest canopy, limitation of remote sensing product, high variability of fuel, and construction fuel models. Future technology for mapping fuel needs to meld all approaches to create the most useful maps. And then ecosystem simulation modeling will play an important role in quantifying those gradient responsibility for fuel distribution, ecological understanding, and fuel map revision and refinement approach. Next. Thank you for your attention. Just my presentation. Thank you.
Thank you very much, Andita. We will, you have to get ready maybe at the end of our session to answer the questions, okay? So thank you so much. Okay, so we will move to next presenter, Mr. Almi Ramadi. So Mr. Almi Ramadi is from Faculty of Forestry and Environment, IPB. So he will present his research entitled Assessing Severity of Forest Fire in Sungai Buloh Protected Peat Forest, Jambi. Okay, the floor is yours, Mr.
Okay, thank you, Dr. Ayu. I'm sorry for operator. Can I share my presentation by myself? Okay, thank you. Okay. I think I have a problem. Okay, wait.
It's okay, we will wait. We have time.
Okay, I think I have a problem. Please, operator, can help me to share this presentation. Okay, thank you for operator. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Almi Ramadi. I am a student in IPB University, and for now I will present my presentation. The title of my presentation is Assessing the Severity of Forest Fire in Sungai Buloh Protected Peat Forest in Jambi. Next, please. Next. Okay, next. Okay, for my background of this resource is the occurrence of forest and land fires at the end of 2019. And it has burned around 1,600,000 hectares of forest and land in Indonesia, and of which an area of 400,000 hectares is peatland area based on MOF 2021. And the fire can increase the environmental damage, such as fires on peatland. And one of the peatland area affected by this incident is the Sungai Buloh Peat Protected Forest, or we can call that with Hailgi Sungai Buloh. And then to reduce the impact of fire on peatland, we must do some treatment. We can something like rehabilitation. And the first step before we start rehabilitation, we must monitoring the severity. And in this research, I focus to monitor the severity of forest and fires. And it is so important so that the rehabilitation process can be maximized. Monitoring the severity of forest and fires. Here we can use remote sensing. You know, remote sensing is the newest technology in forestry. And with the satellite imagery data, we can analyze the severity of forest and fires with normalized burn ratio index. Here in this research, I use this index because NBR is the best index for monitoring fire. Next, Indonesia's administrative boundary data. And the important data of this research is Sentinel-2 image data. My image has used in this research is Sentinel-2 MSI level 2A with acquisition date in September 8 and November 7, 2019. If you want to look the image of our data, my Sentinel-2 image data who I use in this research, you can look in figure 1. Next. Okay, for data processing procedure, I have many steps here. And first, I must create monthly hotspot data and monthly precipitation to get an estimate of fire time. And then after that, I create the estimation burn area by visual interpretation method. And before I do interpret, I must create composite image with a combination of RGB, band 12, 8, and 4. And after that, I can delineate the area by an off-layer delineation technique. Next. And then after that, I create estimation of burn area by index image creation. I use here normalized burn ratio NBR or NBR. And after that, I create burn area by the difference value of each pixel in NBR pre and NBR post. And the last step is create training data by using the NBR index. The training data are correspond to the area suspected fire for visual interpretation. Okay, next. Okay, this is the formula of normal burn ratio or NBR I used in this research. Next. This is the formula for delta NBR to create burn area index. Next. Okay, for data analysis procedure, I use 4 steps to this research. Okay, next. Okay, first there is the identification of burn area. A pixel is declared as a fire area if it meets the requirement as follow 8 or PGL 2015. If complete the requirements if condition 1 NBR post is lower than alpha and condition 2 if delta NBR more than beta, you can calculate the alpha and beta with this formula. And then next. Next, please. Okay. For after that, I create estimation of fire severity using the threshold, and I separate this class in the 3 class. There is low, moderate, and high, and I use this threshold formula to create this class. Okay, next. Okay, for after that, I must measure the ability of NBR. Here I use the distance value, or we can call that D value, based on the formula developed by Kaufman and Riemer in 1994. And you can look here the formula of D value, and we can get the result about the reliability of index. If D value is more than 1, the index has good ability to measure fire severity. If the value of index is lower than 1, the index has a poor ability to measure fire severity. Okay, next. Okay, for accuracy test, I use individual classification success index or ICTS according to Cocles and Blackburn in 2001. And okay, next. Okay, next. Okay, you can look here in our result. My result is in figure 2. The distribution of hotspot in 2019 at Hagesnebo is only found in September. You look at in September is only hotspot has found in that 2019. And then if you look in the figure 3, if we look the hotspot distribution only in September, the hotspots start on 10th and the end to the 26th. And if we look at the relationship between hotspot and precipitation shows a strong relationship. The higher the monthly precipitation, the lower of the number of monthly hotspots and vice versa. If you look that in figure 3, if in depth of 15, there are precipitation in that, and the hotspot will decrease because the precipitation value is increased. And based on this analysis, we can get the result that the estimate of burn period in Hagesnebo is from 10 to 26 September in 2019. Next. Okay, for burn area assessment from visual interpretation method, I create the delineation and interpretation burn area based on the characteristic of burn area in RGB composite image. There is reddish brown, which is darker than surrounding color, and is in the form of a rectangular polygon. You look here in figure 4. There are 2 locations about burn area. Next. Okay, after we can identify about the burn area based on composite band, the area of fire using visual interpretation method is 366 hectare. And then this data used as a training data area in identifying burn area, and this is used as reference data in the index processing accuracy test. Next. Okay, this is the result of NBR in figure 6. Yang in picture A, there is NBR pre or before fire, and figure 6 in B picture is the NBR post or after fire. This show that found a decrease in the NBR index after fire. You look, there are 2 locations. In the value of NBR has decreased. This because the vegetation after burning in the area has low reflectance to the near band and high reflectance to shear band. Next. And we can get the burn area with delta NBR. And you know, look the indicator of this method. The burn area is interpreted if it's closer to the value of 1 about the delta NBR. Based on the figure 7, it is expected that there are 2 areas where being burn area in Hagesnebo. Next. Okay, if you look the statistic data average, it show the NBR pre 0.5 and NBR post is minus 0.03, and this is show the decrease value of NBR significant. Okay, next. Okay, this is my result for assessing burn area with digital method, and the total area of estimated burn area identified by the NBR index is 351 hectare. Next. Okay, for fire severity, I use this threshold based on my training data, and the severity class in Hagesnebo is dominated by high class with 59%. Or 200 hectare. Okay, next. Okay, for ability test, NBR has a very good ability to measure fire severity. You look that in the value is more than 1, so we can get the result that the NBR has a good ability. And we look the accuracy is 91%, And the height of the value accuracy of the NBR index is because the NBR index uses a square band, which has a higher sensitivity than other band in multispectral image. Next. Okay, if we look the relationship fire severity and groundwater level, the period, this is in figure 10, is show the GWL in higher Sungai Buloh. The period of July to December show different GWL patterns compares the period of January to June. If you look in A, that dominated by pink color, you know, and the interpret of pink color is depth of GWL if minus 14 to 0 centimeter. If we look in a yellow color, and the interpret of the color is the GWL depth is minus 68 to minus 54 centimeter. This shows the decrease of GWL. That's because the distribution, if you look in figure 11, distribution of monthly precipitation and GWL in August Negro in period July to December has a decreased value of precipitation. Okay, next. Okay, for if you look the relationship between precipitation and GWL, precipitation had a significant effect on GWL with the value of significant F is that 0.03, and there is a lower, the value is lower than 0.05. And this has shown that this was significant effect precipitation and GWL. Okay, next. Okay, if you look the relationship hotspot and GWL, fires in higher Sungai Buloh may start to occur due to the dry peatlands during the drought. If you look in September, it's only found the hotspot, and in that month is the lowest GWL in that around of 2019. That's show that indicates that the fire occur following a precipitation pattern. So it's important to keep the GWL less than 40 centimeter from the surface to reduce the risk of fire. Okay, next. Okay, next. This is my conclusion. In Harga Sungai Buloh is dominated by high class severity, and the NBR index has a good ability to estimate the severity. And the second conclusion is the high severity of fire that occur is caused by the dynamic of the groundwater level, which is strongly influenced by precipitation. Okay, next. Well, this is my references. Next. Okay, thank you very much for your attention to me. I have quotes from Theodore Levitt. Creativity is thinking up new things. Innovation is doing new things. I'm Almer Ramadi. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih. Thank you so much, Mr. Ami. So you stand by for question and answer session after this, okay? Thank you so much for the. So I would like to invite our third presenter because actually the last presenter for this session because I didn't receive any updates from the other two presenter, which those who cannot be with us today. So we move to the last presenter for this session, Mrs. Rosita Ahmad. So Rosita Ahmad is from Forestry Research Institute, Malaysia, FRAME, with her title, Effects of Carbon Dioxide Enrichment on Selected Soil Properties at Tropical Forest in Jengke, Pahang, Malaysia. So Ms. Rosita, floor is yours. Thank you.
Thank you, session moderator, Dr. Siti Nur Hidayu. Assalamualaikum and a very good afternoon, ladies and gentlemen. Please bear with me for the next 10 minutes, having to look at the same poster. This paper is co-authored together with my colleague, Cik Muhammad Fakri, Puan Nur Hafizah, Dr. Azian, and Nik Nur Afida from FRAME. Okay. To start with, anthropogenic sources from human-caused activities have greatly increased atmospheric concentration of water vapor and greenhouse gases. Increase of greenhouse gases emission causes heat to trap near Earth surfaces, resulting global warming. Carbon dioxide contributed the highest percentage, about 76% of total greenhouse gases, and this may be related to its fast rate compared to the other greenhouse gases. Climate change from temperature increment, moisture, and elevated carbon dioxide has the potential to threaten food security through its effect on soil properties and aid processes. And forests can play an important role in mitigating carbon dioxide emissions through carbon sequestration in soils. Direct plant carbon sequestration occurs through photosynthesis process, utilizing atmospheric carbon dioxide into plant biomass. Subsequently, some of this plant biomass is indirectly sequestered as soil organic carbon during decomposition processes. Here, we study the effect of elevated atmospheric carbon dioxide on the change of various soil parameters under free air carbon dioxide enrichment system phase carried out in tropical forests in Pahang, Malaysia to understand the climate change adaptation. Soil changes in control plot with no carbon dioxide elevation was also studied as comparison to the carbon dioxide 2017, and the carbon dioxide concentration release was in the range of 480 to 520 ppm per month. The control plot was set up 200 meters away from the phase area. Soil was sampled before the treatment began and after gas release for a period of 2 years. At the two soil depth, 0 to 10 centimeter and 10 to 30 centimeter. And seven soil parameters were examined. And as you can see in the graph bar, the left bar in the graph indicate the control plot, and the right bar is the phase site. The white color indicate initial reading, and the color field refer to after 24 months. It was observed that a period of 2 years for soil properties, that is soil moisture, pH, organic carbon, and assimilable potassium in soil show an increase at 0 to 10 centimeter depth under elevated carbon dioxide condition. However, the trend was observed in the control plot where the soil parameters show a decrease at the upper soil layer. Tropical forest is a complex ecosystem. The changes of soil properties in forests is closely related to plants, environment, and weather. Let us look at the soil pH. Okay? The soil pH at both the study plot are acidic. After 2 years of carbon dioxide exposure, the upper soil depth is 0 to 10 centimeter in the phase area, indicated a slight increase in pH value of 4.05. Increase of soil pH may be due to the soil buffering of the cation exchange with hydrogen ions and mineral solubility reaction. And this is tally with the high increase of soluble potassium here. A different trend was observed in the control plot where soil pH show a decrease in both the soil layer after 2 years. The decomposition of plant residues may lead to the formation of organic acid and causes a decrease in soil pH value. Next, we go to the soil moisture content, MC. Okay, after 2 years of carbon emission, the percentage of soil moisture content in phase plot show an increment of 24% in both the soil layers. The increase of soil MC is tally with the increase in organic carbon here. Organic matter deposit from plant may trap moisture at the upper soil layer and increase the percentage moisture content. Continue with organic carbon. Okay. Before the experiment began, the soil in the phase plot recorded 1.2% of carbon content at the upper layer, and the amount increased 22% more, 22% more after 2 years fertilized with carbon dioxide. According to bios, the increase in carbon content may be contributed by plants through dead leaves and roots, and this provides carbon input to the soil indirectly. However, opposite pattern was observed in the control plot with a decrease of 12% carbon at the upper soil layer. The decrease of soil carbon at the upper layer could be related to the decomposition of organic material under normal tropical conditions. Okay. Next is assimilable potassium. The increase of carbon dioxide in the environment for 2 years show high increase of assimilable potassium, about 75 to 140%, about 140% increase in all the soil layers examined from the face side. Increase of carbon dioxide may increase in temperature, resulting in decomposition of organic matter for nutrient release, while the amount of potassium in the control plot shows small decrease at the upper layer after 2 years, but no significant change at the lower layer. We continue with the other soil properties here on the right-hand side. These 3 soil properties that show similar trend between the face and the control plot at the upper soil layer are total nitrogen, available P, and assimilable aluminium. Let's go to the nitrogen. Okay, it was observed that there was an increase of N content at both soil depth in the control plot after a period of 2 years. The percentage increment range of 16 to 22% may be related to the increase in plant litter. Similar trend was found at the upper layer in the face side, with the nitrogen content increase about 11%. Okay. This may be related to the decomposition of organic matter releasing the plant nutrient. However, the percentage increment of nitrogen in the face area was found lower compared to the control plot. Okay. Furthermore, the nitrogen concentration reduced at 40% at the lower layer at face side after the area was exposed with carbon dioxide. This may be attributed to the decomposition of organic matter did not occur rapidly to release nitrogen. According to Philip and Van, stated that increase in carbon dioxide in the atmosphere might increase the activity of microorganisms in the soil, which led to faster decomposition of organic matter. However, this situation did not happen here as expected. This may be related to the acidic of soil pH is not ideal condition for the microorganism. Next is the available P. The control side recorded 54% in the upper layer and 28% increase of available P in the lower layer at the control side. At acidic condition, P may become less mobile and unavailable for plant uptake. And similar trend was also observed at 0 to 10 centimeter depth at the face area. But the changes of soil available P from the face side was found greater compared to the control plot. The P content in soil at the face plot detected 63% at 0 to 10 centimeter and 84% reduction at the lower depth. The reduction of P in face soil may be associated with increase of nutrient uptake by plants. According to Gabito, increase in carbon dioxide induces plant growth, resulting in increase in nutrient uptake from the soil to support plant metabolism. Lastly, assimilable aluminium. Both the study plots recorded similar trend of assimilable aluminium in soil after 2 years of inspection. That is decrease of aluminium at the 0 to 10 centimeter depth and increased amount of aluminium in 10 to 30 centimeter depth. However, the changes of aluminium at the control plot is higher compared to the face side. And acidic pH has effect on the availability of acidable aluminium in soil. In conclusion, during gas release, carbon dioxide interact with soil matrix and water, causing changes to soil properties. Moisture content, pH, organic carbon, and assimilable potassium in soil will enhance at 0 to 10 centimeter depth under elevated carbon dioxide condition after a period of 2 years. However, opposite trend was observed in the control plot under the tropical forest ecosystem, while similar pattern was detected for nitrogen, P, and aluminium in soil from both the control and the carbon dioxide fertilized plots. There was an increase in nitrogen content and decrease in P and also decrease in aluminium at the upper soil layer, despite the study area was or not treated with carbon dioxide emission. However, the effects were more for potassium and P inside with high carbon dioxide concentration compared to the control plot. With this, I end my talk. Thank you for your attention.
Thank you very much, Mrs. Rosita, for the presentation about the soil enrichment just now. So we'll proceed with our discussion. Yeah. So I hope that 3 presenters are ready with to answer questions. If there's any questions from the floor, please just turn on your mic and then ask questions to the presenters. If you wish to just type your questions on the chat box, you could do so too. So we'll just wait for if there's any questions from the floor, okay? Okay, maybe I will start first, yeah? So I will start my questions to the first presenter. So maybe if there's other questions from the other participants, you could just continue after this, okay? Just to start the discussion, okay? So for the first presenter, Ms. Andita Mindamura, so I have several questions for you. So I was aware from your presentation that you use Mrs. Andita, are you with us?
Yeah.
Okay. I just wonder about your presentation, yeah, about your research. You did mention about the traditional methods you use to locate the potential across the landscape, right? You did mention about the field work and also other spatial data that needed even for the conventional method. But for the field work, what type of data was taken for the conventional method?
What the data that we get to the next step? Right?
No, for the conventional method, I mean the traditional method, because yours is using the GIS and sensing, right? So for the conventional method, the traditional method, so what's the difference? And then could you explain more on that?
Okay. Thank you, Dr. Siti, for the question. The traditional method that researchers in the field fire management use in the field, they get some fuel in the field with the manual use, like
boleh cakap Melayu juga, tak ada masalah.
mengukur like scaling the diameter with the meteran, with the pengukur, and then collecting the data from the field to the laboratorium. But in the modern, we can use the GIS and spatial analyze to get the data from the canopy cover to the to the ground with the leader. But the expensive cost if we use that from the student, right?
Because you will have to bought all the map,
Yeah.
right? Yeah.
Mm-hmm.
Okay. So
that's why the field map it's costly and very difficult to do in the field.
Okay. So this the modern one is the more reasonable. Yeah. Okay. Easier. Okay. The other question is also related to your GIS part, because you using, you know, the different regions have different environmental factors, different weather conditions. Yeah. So this also may affect the type of fuel. So is there any probability that spatial resolutions and spectral resolutions of the satellite image influence the detection of your the fuel types of the different regions? Have you observed that?
Yeah, I'm observed with the JS. I use the Sentinel-2 data in the second step of my research in to my dissertation, and then the final of project my dissertation is to management conservation area and build the forest management to the Berba and Sembilang National Park with the fire management like in Canada that adopt in Indonesia, and FDRS, National Forest Danger Rating System, and we try to build in the specific area in Berba and Sembilang National Park as peatland in Indonesia.
Okay. Okay, thank you so much. And
Thank you, Dr.
yeah,
Siti.
I will wait for if there's any question for you. Yeah, just if there's any questions, just turn on your mic and then you could ask questions to presenters directly. You could also tell us who's the questions for.
Excuse me, can I ask?
Yes, please. Please
Alright.
proceed with the question.
Thank you. First, my name is Kresna. I'm from IPB University, and I want to ask to Almi. Okay, so Almi said that it is important to maintain a groundwater level on peatland to below or less than 40 centimeter below the ground in order to prevent or reduce the fires and prevent the peat degradation. And I want to ask you, is it possible a fire occur in a peatland with if the groundwater level is below the 40 centimeter, and how it could happen? All right. Okay. Thank you.
Okay, Almi.
Okay, thank you to Kresna for your question. This is very best question, I think. Okay, I will try to share again my presentation. Okay. Okay. Especially in Hayage Sungai Buloh, you look here, the burn has happened in September, you know, and I start with explain with this figure in figure 10. The jewel value in January to June, and you know, if we look in here in figure 11, in January to June is wet season, you know, and in July to December is dry season. And if you look in this figure in this picture, in January, I think if you look here in pink color in my pointer, is we can interpret that the color is minus 14 centimeter to 0 centimeter, and it is show that upper than 40 centimeter. That's good. That's good for save the area from the fire. And then after we look here in July, in the same area in my pointer, it show that the yellow color, and we look here in description. In here is depth minus 68 centimeter to minus 54 centimeter, and it show that below 40 centimeter. You look there, and the fire has happened in Hagia Sungai Buloh in September. If you look again in September in H, okay, this show that the GWL is lower than 40 centimeter, and then okay, look here in September, it's only month has found hotspot, and there are more than 100 hotspot in September. And you look here in the value of GWL is minus 57 centimeter, and here show that below of 40 centimeter. And if you look in July is include the wet season in Hagia Sungai Buloh, and then there no found the hotspot in that month. So I just according to the rule of government, our government, that the kid must save in must not lower than 40 centimeter from the surface, because that will create the risk to that can be fire if the GWL less than 40 centimeter. So I think the minimum to save the peatland area from the fire is we must keep the GWL keep minimum in 40 centimeter, and better if the value of GWL is above of 40 centimeter. I think that the answer.
Okay, thank you. I hope that answers your question. Yeah. So, is there any other questions for all three speakers? Ada lagi? Maybe I can start ask questions to Mr. Ami. Is it okay?
Okay.
Okay. So I just wonder, maybe I missed a bit your presentation, but I wonder how you did your verification for the threshold, and also for the D value for the fire severity. You might have mentioned it somewhere in your presentation, but maybe you could share it again with us. I missed the information maybe about how the verification part.
Okay. Okay, for my threshold to fire severity.
Yeah.
Is that right for your question, Doctor?
The verification for the threshold and also the verification for the fire severity. Did you did any? I'm not sure about maybe field work after the event maybe.
Okay. In this research, I don't measure the severity in the field. I just measure that only from the remote sensing from the satellite imagery, and here I just use my my threshold here in low, moderate, and high. That's from my training data. That's based according the LAPAN. This is the formula of my threshold. This is best for, I think this is the formula according to LAPAN in 2015, and after that I just measure that with Sentinel-2, and yeah, I just the end of my research, only that. I don't measure that in the field. Maybe I think there is I can do that in for the future to verify this measure.
Yeah, then you can say that you already verified the value, right? Okay. It's okay, just a suggestion. But if your scope is just until this, that's fine. Thank you.
Yes.
Thank you so much. Okay. So is there any other questions to the speakers? especially our third presenter, Mrs. Rosita. Okay, so maybe I could start first with for Mrs. Rosita. I just wonder about the effects of this enrichment to the ecological response in our forests. Maybe you didn't observe that, I'm not sure, but if you have any information on that.
Thank you, Doctor, for your question. Actually, under this phase project, we are divided into many components, soil components, insect, and insect group. So for my group, we focus on soil. So actually, I haven't got any information on the insect. That will be another group that will be focused to look into on the insect, and also there's also on the on micro and also microbes.
Microbes as well.
Yes.
Yeah, because I thought that maybe because the acidity of the soil, you observe that on the soil condition, maybe it will also affect other like microbes in the soil, and also the little layers, maybe all the processes in the forest.
Yes.
Yeah. So, and the other thing is about the scale. I'm not sure about if you mentioned anything about the size of your plots or the scale. So I assume this is a small scale study, or is it big scale? And is there any like if there's different scale of study, will you observe different findings?
Actually, the scale of the structure phase is 93.5 meters squared, and control site also about that area. So we compare, make comparison. Okay.
Yeah, but if there's any, just in case if you conduct the study in a big scale area, would you observe different results?
Yes, there is a bigger structure that is intercom.
Okay.
The camp, they also build the structure, phase structure intercom that is more bigger. And so far, we haven't proceed with that research yet. Intercom. Okay.
I found it really interesting. I think this research, and where the direction of this, where this will go, what's the end results of this research? You're talking about this other different aspect of the study as well, right? Like insects and other groups. So where's the direction?
The study will continue. The first phase is for 2 years, and then it will continue taking the data for all the group for 5 years. So we will monitor the changes in the.
Okay, thank you so much, Mrs. Zita, for answering the question. Is there any other questions from the floor?
I want ask Kak Andita.
Boleh, silakan.
Okay, thank you for this chance to be. I'm so interested about the topic of Kak Andita, and because at this time we just measure the biomass with NDVI, with NDVI that based on density vegetation, and this, I think if this idea can be realized for now, it can help to employ in the field. So I want ask your opinion about how can we monitor the field under the tree canopy. If we look on the take a picture in above or in the sky, it's only take the cover. Maybe if something like branches or litter in under of canopy, it cannot be measured for the satellite. So how about your opinion to that?
I get it. Okay. Thank you, Almi, for the question. It's a good question. That my problem too in the field. actually. How to make sure all of the tree and the structure, we can make sure it can be get to the good data and the processing in the computer and make it experience in the field. I with Professor Bambang and Prof Lily, we we get the data with the OBIA, with the OBIA data with the what can I say with the multiple multiple digital georeferencing, and then multiple spatial to get the data. Like say we use the Sentinel-2 to get the canopy cover, and then we use the let's say the other spatial to make sure the brands and in the surface fuel. Maybe it can be alternative to get the data. Despite we can get enough money to use LiDAR actually. But if we can use LiDAR, it's a good one for the data. Thank you, Almi.
Okay, thank you. So the conclusion is we must spend more money, right?
Yeah, more money, more time.
Okay, thank you.
More energy. Okay, thank you.
More motivation as well.
Yeah.
Okay, thank you so much for our all lively speakers. I think even though we have only 3 speakers in this room, but I think it's really inspiring. It's really informative. Yeah, our discussion and also all the presenters. I would like to say thank you so much. I would like to end this discussion. I would like to thank all speakers and all participants for joining this room. Yeah, and also I was informed that this session is also on YouTube as well, right? So all the participants there as well. So thank you so much for sharing all the information, knowledge, and also experience with us. So let us give some applause to all the speakers and all the participants. Yeah, thank you so much. Okay, before we end our session, could we turn on the camera so I could take a photo of all of us for the organizing committee? Yeah. Okay, nice. Okay, say cheese. 1, 2, 3. Thank you. Okay, thank you so much, everyone. So hope we see you again next time. Thank you. Bye-bye.
Terima kasih.
Okay, terima kasih.
Tertarik dengan flora fauna yang ada di hutan?
Senang berpetualang ke alam bebas?
Atau ingin turut andil dalam melestarikan hutan di Indonesia?
Fakultas Kehutanan dan Lingkungan IPB University bisa menjadi pilihan yang tepat
Untuk kamu. Fakultas Kehutanan dan Lingkungan IPB University memiliki 4 program studi yang pastinya sangat keren. Pertama, manajemen hutan. Di sini, kamu akan mempelajari cara mengolah hutan dari mulai membuat perencanaan, kebijakan, hingga cara memanen hasil hutan secara lestari, baik kayu maupun non-kayu.
Kedua, hasil hutan. Beragam hal bisa kamu pelajari di sini, seperti pemanfaatan hasil hutan dengan baik agar bernilai jual tinggi, dan cara memaksimalkan produk kayu dan non-kayu dengan teknologi yang canggih dan modern.
Ketiga, konservasi sumber daya hutan dan ekowisata. Sesuai dengan namanya, kamu akan mempelajari flora fauna dan konservasi sumber daya yang ada di hutan, serta pengelolaan suatu ekosistem agar dapat dikembangkan dari sisi ekowisata.
Terakhir, Silviculture. Pada program studi yang dikenal dengan sebutan dokternya hutan, kamu akan belajar tentang cara budidaya bibit pohon agar menjadi unggul, serta belajar tentang rekayasa genetika dan perkembangan jenis-jenis pohon.
Untuk mendukung proses pembelajaran, Fakultas Kehutanan dan Lingkungan IPB University memiliki beragam fasilitas yang sangat lengkap. Seperti hutan arboretum,